All right, 7th graders, it's time to do some distributive property, page 307 in your book. Page 307. So let's take a look. We have two vocabulary words. Equivalent expressions. Equivalent is the fancy word for equal, so it's expressions that have the same value. Okay, and then the distributive property is what we are going to learn. The distributive property is an example of equivalent expressions. An example of the distributive property would be 3 times 2 plus 5. I've taught you in the past to do the parentheses first and get 7 times 3 would be 21. But an equivalent expression to that would be to multiply by 3 before you add. Take 3 times 2 and 3 times 5. So 3 times 2 is 6, plus 3 times 5 is 15, and 6 plus 15 is 21. So the distributive property is something, especially when we get into algebra and you're having some unknowns, it helps you simplify problems out. So let's take a look at the first example. It says, a set designer is building a backdrop for his scene in the play The Miracle Worker. The plywood pieces used for the backdrop are made from a 4-foot by 6-foot rectangle joined by a 4-foot by 3-foot rectangle. What two expressions could you use to find the area of wallpaper needed to cover both pieces? So here's a picture of these pieces. There's one, the 3-foot by 4-foot, then the 6-foot by 4-foot. And notice if you put them together, they're still the same width. They're all 4, but the other is 3 plus 6. Okay, so what we can do for area is you could do it two ways. You could say, hey, the area of this one is 12 plus the area of this one, which is 24, and the answer would be 36. Or you can do it, take 4 times 3 plus 6, kind of like we did in that example. 4 times 3 is 12, plus 4 times 6 is 24, and the answer comes out to be 36. So you can look at it as two separates, or you can look at it as a whole. So they're showing the two ways to do it. Okay, so suppose the set designer joins a rectangular plywood with the dimensions 2 feet by 7 feet to a rectangle 2 feet by 4 feet. So I don't know if they're going to show us a picture, but let's say this is 7 feet by 2 feet, and this one is 2 feet by 4 feet. If we combine those together, it would be 2, and this would be 4 plus 7. You would pull these together to make this one. Okay? So this would be 2 times 7 plus 2 times 4, or this one would be 2 times 4 plus 7. That would be 14 plus 8. That would be 22. That would be 2 times 11, which is 22. Let's see how they did it. Same over there. And then we should put the label because it is area. Feet squared would be the label. So here's our distributive property. Algebra. For all numbers a, b, and c, a times the quantity b plus c, and I'm right here, a times the quantity b plus c is a times b plus a times c. So basically, let's use this word distribute. I'm distributing the a into the parentheses by multiplying. Since there's nothing between the parentheses and the number, it means to multiply. A times b, a times c. Okay? If it's subtraction, you just go a times b minus a times c. So it's a little easier to see with numbers. This one you'd go 8 times 10 plus 8 times 4. This would be 3 times 4 minus 3 times 2. And you could do those out also. So it says use distributive property to write an equivalent expression. Check your answer. So you're going to take this number on the outside and you're going to distribute into, and I always make these two little loops to remind me to do it twice. So negative 4 times 5 is negative 4 times 5 plus negative 4 times 8. And usually with numbers, they want you to go ahead and multiply those out. I don't know if they, well, let's go ahead and do that and check it. Okay, so this one's going to be negative 20 plus negative 32, which is negative 52. Let's try it. That would have been 13. 13 times 4, 2 carry the 1 would be negative 52. So this one, 4 times 50 is 200 minus 4 times 3, which is 12. And that answer comes out to be 188. 7 times 9 is 63 plus 35, 98. Multiplied it out like we did, and then check it. B, we got it, 188. Yep. C, and then 98. Is that what we got? I don't remember. All right. Lava lamps. You're buying 8 small lava lamps as door prizes at a disco party that your school is having. Each lava lamp costs $15.95. Use the distributive property to find the total cost of the lava lamps. Now, one way to do it is to think of $15.95 as $16 minus 5 cents. That would get you $15.95. So to use your distributive property, you would take 8 times 16, which is 8, carry the 4, which is 128, minus 8 times 5 cents, which would be 40 cents. So $1.28, or excuse me, $128 minus 40 cents would be $127.60. Minus the 40 cents, subtract it, $127.60. The hardest part on that one is seeing that $15.95 can be written as 16 minus 5 cents. Use the distributive property to write an equivalent expression. Check your answer. Okay, so 6 times, this one is the backwards. There's a 6. If you take it out, you can either put it in and take it out. They already had put it in, so we're going to take it out. That's what we did. This one, let's put it in. So it's going to be negative 6 times 12 plus negative 6 times 3. So we're just distributing these in. So this is going to be 8 times 12 minus 8 times 5. This times this, this times this. We're just distributing that in. Now this one's opposite. We're going to take it out. Okay, see what we get? 3 times 11, 3 times 4. What if, suppose in example 3 that each lava lamp costs $17.90. Find the total cost of buying 6. Okay, so $17.90, that's the same as like, how about $18 minus 10 cents? And you're buying 6 of them. So 6 times 18 would be 108. 6 times 10 cents is 60 cents, so 107.40. There we go. Okay, so practice the distributive property. If you have any questions, please help. I know that was a little crazy, but see if you need help, please ask. Talk to you later.